Hello students. In this part of system classification, we will look into linear system versus non-linear system. So there are two kinds of system that we can classify. One is called as a linear system. What is a linear system? A linear system is a system which follows the principle of homogeneity and superposition. It follows the principle of homogeneity and superposition. What are the principles of homogeneity and superposition? Basically, it can be summarized as given in this particular equation here, wherein in one side you are having transformation when the input is this. That is, the system output is written as transformation of the input, and this is the input. And that should be equal to when the transformation of the input, two different inputs are added up together. To understand this, you have to look at this particular diagram. Now in the first case, that is for this particular equation, which is the left hand side, I will now call it as left hand side. In this left hand side, this one, it is represented by this particular diagram, wherein you are having an input x1 of t, which you are passing through a block A to get it multiplied and get it as ax1 of t. So ax1 of t, and there is a second input x2 of t, which you are multiplying with b to get you bx2 of t, and both of them you are adding up. And once you add them up, you are basically passing them to the system, which gives you this transformation, and that is basically the output y of t. And in the right hand side, you have two systems. That's why you are having two transformations. So you are having two systems in which you are individually putting x1 of t, and that is passing through the system, and the output of the system is now multiplied with a. Similarly, in a duplicate system, a signal x2 of t is passed through and the transformation we get is y2 of t, which you multiply with b, and finally you add both of them together and you get the signal y of t. See, what you have to understand is, why is this called as the principle of homogeneity and superposition? Homogeneity is because you are multiplying with a, and superposition because you are adding it. See, what this tries to say is that if you are taking two totally different signals, adding them up and then passing through the system, the output should be equal to when you are taking the one signal, passing it through the system, another signal passing it through the system, same system, and then when you add up, and then what you get as the output, both of these systems or both of these should have the same output y of t, and that is why this equal to sign. If that is followed, then it follows the principle of homogeneity as well as superposition. And if that is possible, then we can say that the system is basically a linear system. I will just give you an example. You might be thinking, it's a straightforward thing. Why should there be any system which is not linear? Well, there are many examples. I will just simply give you an example. Suppose you are having a signal or system in which the system basically squares the output. So whatever is the input, that input x of t is getting squared. Okay, and that is what you will get at the output. Now suppose if I am taking two signals, okay, if suppose I am going to take two signals, one is having a value of 2, another is having a value of 2, I am adding it up, and then I am trying to look at the output. What will be the output? So you can see that 2 plus 2 will give me 4 and 4 square will give me 16. Now contrast that with another case wherein you are not sending this 2 and 2 into the same system, you are sending through duplicates. That means you are sending through the same kind of system, but they are sent separately. So you are having 2 here, and here you are having what is called as the squaring. So I am getting x square, x square. So whatever is the input, at the output I will get the square of that, and that I am going to add it up. So in that case I will get here 4, here also I will get 4, and the adding up I will get 4 plus 4 is equal to 8. So is 16 equal to 8? It is not the case, and that is where we say that the system is not linear. So there are many systems which are linear and there are many systems which are not linear. Let us look at some solved examples to understand them. Before that, let us finish the definition. So this is for the case of continuous time system. The same will apply for a discrete time system. In discrete time system, the only difference is that the equation is now with respect to x1 of n, x2 of n. That's all. I'm not going to draw a separate diagram for this. It is one and the same. And what are a nonlinear system? Nonlinear systems are those systems which do not obey the principle of superposition and homogeneity. So now let us look at some of the solved examples. So here we are having a situation wherein the input and the output is basically given by this particular equation. So I have to pass this through this kind of a system and then see if the left hand side and the right hand side both are same. Then first I will write from the principles of homogeneity and superposition. I have an equation, and given the equation of the system, we can find the LHS as the LHS for above system we get by substituting this as the input, wherever there is x, and based on that whatever is going to be the y value. So you can see that straight away I will substitute this and I will get the LHS as, for the case of LHS, this equation, where you can see all I have done is, instead of y of t, I have substituted two inputs based on this equation, or two outputs based on this equation. So if I am having an output of y1 for x1 and y2 for x2, then basically I can write this as this. So what we have got here is an equation for the left hand side of this homogeneity and superposition equation, and now we have to find out what will happen when we pass this system, when we pass separately x1 and x2 through this system, and will these two, that is LHS and RHS, be equal to each other. So let us see. So I will say, since input is x1 of t, output will be, so now I am going to look at the equation and I am going to write the output. So the output is basically given by this particular equation. So d by dt square of yt, where yt will become y1 of t and 2t will become 2t y of t will become 2t y1 of t. So based on that I will write the equation as d square by dt square y1 of t plus 2t y1 of t, and that will be equal to t square xt. So I will write t square x1 of t. Similarly for x2 of t we get, d by dt square of y2 of t plus 2t by 2 of t is equal to t square x2t. So what am I doing here? I am actually taking the individual signals, as you can see here. Now I have got the output of those, which is given by this particular equation that I just now wrote. Now I have to multiply each one of them with A and B separately and then add them together as it is shown in this particular diagram. So just now I have got the equation for this particular system 2. For the first one I will multiply with A and the second one I will multiply with B, add both of them and I should get y of t, and let's see if these two are going to be same. So then I will write therefore linear combination of both will give. So let us see if what the equation is going to be. So now I have to multiply the first equation, that is this equation, with A and the second equation with B, and then I have to add both of them. So I will get a d square by dt square of y1 plus 2ta y1 of t. See, what we have done is we have taken the equation 1, we have multiplied with A and we got this part. Similarly, we took the equation 2 and we multiplied it with B and we have got this. Here I should have written B, sorry, I should have written B. So we get B here, and similarly we get a B here. So that is what we have done. We have basically multiplied A with the first equation and B with the second equation and added them both off together. And now I will rearrange the equation and see how it looks like. So what I am going to do is I will try to bring the derivative side together. So you can see here I can take easily A inside. I can easily take A inside this particular differentiation because A is a constant. I can take it inside. Similarly, B I can take it inside, and since both of them are going to be differentiated with respect to t square, I know that both of them can be added up into a single entity. So I will write d square by dt square into, so I will write a y1 of t, and then for this case, for the second case, I will write plus b y2 of t. So I have added them both up. So that part is done. That means I have added these two together. Now similarly I can add these two. Here 2t is common. So I will write that as plus 2t, and then the remaining portion I will write together, which is a y1 of t plus b y2 of t. And then the other side I am straight away going to take t square as common, so I will get t square a x1 of t plus b x2 of t. So now what I have got, I have just got the RHS. So this is RHS, and look at LHS. LHS is the previous one. If you look at LHS, this was LHS where I forgot to write the right hand side, is equal to t square a x1 of t plus b x2 of t. So you can see that this LHS that we have got for this equation, now this is the LHS that I am talking about. The answer for this is basically this equation, correct? And the answer for the right hand side is basically this equation. And you can see that both the equations are matching. And since both of them are matching, I can say that this is RHS, and RHS is equal to LHS. Therefore, the system is linear. And this is the method to find if a system is linear or not. Let us try another question. So the second question is 2 d by dt of y of t is equal to 5 yt is equal to x squared t. So first we will write the principle of homogeneity and superposition, which is transformation of a x1 of t plus b x2 of t should be equal to a transformation of x1 of t plus b transformation of x2 t. So first let us look at what happens to the LHS. So from LHS we will get, so here is the equation 2 d by dt of a y1 of t plus b y2 of t. So look at this right hand side, this equation. As you can see, it is x square of t. So I have written what is the total signal given, and this is the square of it. We know that we can actually take, just like a square, a plus b the whole square. I can write this equation as a square x1 square of t plus 2ab x1 of t x2 of t plus b square x2 of t. So this is the equations. Now let us look for what will happen when we individually give them in this particular equation. If we individually go from if we individually try to calculate the right hand side of this equation. For x1 of t we have written the equation where we have actually written everything with respect to y1. I should have written this one also as y1. Yeah, so all with respect to y1 and x1. And next for the x2 of t we have 2 by d by dt of y2 of t plus 5y2 of t is equal to x2 square of t. So you can see this equation is of x1 y1, this equation is of x2 y2, and according to what we have seen in the diagram, if we have to carry out this particular equation, then we have to multiply with y1 with a, b, and then see what the equation is going to look like at the output. So a linear combination of both will give. So as you can see in this equation, I have multiplied first equation with a and the second equation with b, and I have basically added both of them together. Now I can rearrange them and I can write it. The first two parts I will join them together, so I will get 2 times d by dt of a y1 of t, okay, plus I'll take this particular part also, the second part I will take, so that is going to be b y2 of t. So now the differentiated part is over. Second part is 5 a y1 of t, and here also I am having 5, so that 5 I will take it commonly, so I will get plus b y2 of t. That is also okay, and that is going to be equal to a x1 square of t plus b x2 square of t. So with that you can see that I have got the right hand side of the homogeneity superposition equation, and if you compare this equation with the original equation that we have just now got here for the case of LHS, you can see that this part matches. It does not matter. This part matches with the second equation. But what about the first part? The first part does not match, and that is where this equation of homogeneity does not hold for this particular system. And so we will be writing, since LHS is not equal to RHS, the system is not linear. Next, let us look into another classification, which is a stable system and an unstable system. A stable system is a system which is defined with respect to Bebo stability. Now what is Bebo stability? As you can see here, it is written BIBO, Bebo stability. What is Bebo stability? Bebo basically stands for bounded input, bounded output. It means that if into a system you are giving an input that is bounded, bounded means it is not going out of limits. It is not going out of limits. If you are giving a bounded input and if you are going to get a bounded output, then the system can be called as a Bebo stable system. That is bounded input, bounded output. BIBO stands for bounded input, bounded output. So a system is called Bebo stable if and only if every bounded input produces a bounded output only. Note that the output of a stable system does not grow unreasonably large. This unreasonably large means its value keep on growing up to infinity. So mathematically, if you would ask, there are two ways of defining it. One is when you are getting a system equation with respect to x of t and y of t. So if suppose you are having x of t whose magnitude, if you would say take, its magnitude is some mx, which is a positive real value, whose value is less than infinity. So if the magnitude of x of t is less than infinity and that results in an output which is y of t whose magnitude is also less than infinity, then the system will be called as a Bebo stable system. We will see with respect to equation how this will come. Another equation that helps in defining stability is the equation of the impulse response of the system. What is impulse response of the system? Right now you need to just look at the word impulse response system. What is the meaning of an impulse response is something that will come in later chapters. But what you have to understand is that any system can be defined by its own equation, which is h of t. See, up till now we have been defining system where the equation was something like this: y of t is equal to 5x of t plus d by dt of x of t. So what is this form of an equation? This form of an equation is basically defining a system with respect to input and output. So with respect to input x of t and output y of t, you are defining an equation which defines what is going to be the output of a system when you give an input x of t. This is one way of defining the system, which is through an input-output equation. There is another way of defining a system in which the system itself is defined by a mathematical formula of h of t, where h of t does not consist of any x of t or any y of t. There is no equation like this. H of t may be something like h of t is equal to e raised to power minus 3t. This is an equation in itself. There is no x of t, there is no y of t. Just like we had a signal defined by x of t is equal to phi u of t, just like that we may have an equation of system which is defined as h of t is equal to e raised to power minus 3t. That means it does not consist of any x of t and y of t. All you have to do is you have to put x of t, some x of t here, and you have to find out some y of t. How do you do that is something that we will see in later modules and all. But you have to understand that there is another way of defining the system, and that is through h of t, where h of t is called as the impulse response of the system. Impulse response. Why is it called as the impulse response is something that you will learn only later. So now if we are having the impulse response of a system as h of t, then the necessary condition for the system to be Bebo stable is that the magnitude of h of t when integrated within minus infinity to infinity should give a finite value. So this is a very simple way of checking. So we will see using these two methods how we find the stability of a system with the help of problems. Let us have an example of stability. So here, determine if the following system is stable or not. So here an input-output equation is basically defining the system. So what I will do is, I will first consider let x of t is equal to u of t, which is a bounded input. which is a bounded input. Why am I calling it a bounded input? If you remember, the input is bounded if the magnitude of x of t is equal to is less than or equal to some finite value. Okay, so it has to be some finite value, and we know that the magnitude of u of t is always going to be equal to 1. So since u of t, magnitude of u of t is 1, I can say that x of t equal to u of t can be called as a bounded input. Then what we see is, then y of t, which is the output, the y of t is going to be equal to e raised to power u of t. Now we know that u of t has two values. So I will say that u of t has a value for t greater than 0, it has a value, and for t less than 0, it has a value. So because of that, y of t will have two equations. One is for t greater than 0, e raised to power 1, and for t less than 0, its value is e raised to power 0, and we know that e raised to power 0 is always 1, and e raised to power 1 is 2.72. So you can see that basically y of t will be having a value of 2.72 for t greater than 0, and t less than 0, it is going to have a value which is a bounded output, which is a bounded output. Therefore the system is Bebo stable. So that is one way of doing it. Let us look at another problem. So here we are having y of t is equal to t plus 2 u of t. So I can write that y of t is equal to, I will open up the bracket, it is t u of t. Sorry, I should have written it as x of t. Sorry. So this is an input output relation, so I can write it as t x of t plus 2 x of t. Now let x of t be equal to u of t, which is a bounded input, which is a bounded input. Now if that is the case, then I will write, then y of t is equal to t u of t plus 2 u of t. Okay, which will have two values. One is, so the 0 I will not write, let me write only the value which is going to be there, which is t plus 2 for t greater than 0. For t less than 0, it is going to be 0. Okay, now what? Now you can see that as the value of t keeps on increasing, the value at t is equal to 1, it will be 3. The value of y of t at t is equal to 100, it will be 102. The value of y of t at t is equal to 10 raised to power 6 is going to be 10 raised to power 6 plus 2, which is approximately 10 raised to power 6. So you can see that the value of y of t keeps on increasing with time, isn't it? Its value is keeping on increasing with time, and it is not going to stop anywhere. It is going to take all the way up to infinity. So I can write that with time tending towards infinity, y of t, or I can say mod of t, is tending towards infinity. Therefore output is unbounded. Output is unbounded. Therefore the system is not stable. Therefore the system is not stable or unstable. So that is for the case of a continuous time signal. Let's look for the case of a discrete time signal, or let us take the case for h of t. Consider this equation, h of t is equal to 2 plus e raised to power minus 3t u of t. Now here there is no x of t, there is no y of t, only h of t is given, and we know that for system to be stable, for a stable system, we know that the equation is integration with respect to t of mod of h of t should be less than infinity, or it should be some finite value. So for that, let us calculate integration of minus infinity to infinity. What is h of t? Mod of h of t is going to be 2 plus e raised to power minus 3t u of t, and I have to take the mod of it, or I have to take the magnitude of it. Now since there is no negative value here, so I can directly write that it is going to be, now since it is u of t, it will start only from 0 all the way up to infinity, and then I will have 2 plus e raised to power minus 3t dt. And we know that for the integration of 2, we will get 2t with limits infinity to 0. And for the case of e raised to power minus 3t, basically I will get e raised to power minus 3t divided by minus 3, and the limit is going to be from 0 to infinity, which you can see this one is going to be infinity minus 0 for the first case, plus for the second case we know that e raised to power minus infinity is going to be 0. So 0 divided by any number is again going to be equal to 0, minus e raised to power minus 3t, t being 0, or e raised to power 0 is 1 divided by minus 3, which is going to be written as this, which will basically become equal to infinity plus 1 by 3, which is actually, you can say, which is equal to infinity. Therefore, since this is the case, therefore the system is unstable. Let us look at a discrete time problem. For the discrete time, we should remember that the equation, this equation which was for the discrete, for the continuous time, this cannot be used. We have to use h of n. So let me write the equation of that. This, wherein you write the equation for h of n for the necessary condition for Bebo stability is summation h of n should be less than equal to infinity. So instead of integration, since it's discrete time, it is going to be h of n. So basically we will use this equation for the case of discrete time. Now let us look at the problem. So now we are having h of n is equal to u of n, and we have to find if the system is stable or not. So first we write the condition for stability. For a system to be Bebo stable, the summation of h of n should be less than infinity. Let us apply that rule here. So if I am going to write summation of n is equal to minus infinity to infinity of h of n, then basically if I substitute instead of h of n u of n, then I will know that the limit for the summation, it will exist only from n is equal to 0 to infinity, because before that it's all 0, and after that the value is going to be equal to 1, which we know that we have to keep on multiplying 1. How many times? We have to keep on multiplying it infinite times, which we know that if you keep on adding 1 infinite times, we will get the value as infinite. Therefore the system is again unstable. Let us look at another equation which involves, let's say, another problem which involves the equation of x of n and y of n. Let us say that y of n is equal to 2x of n plus 4, and we have to find out if this system is stable or not. One of the things that we can do is we can basically find out if, let us do it in this way. Let us say that let x of n be equal to u of n, which is bounded input, which is a bounded input. So now I have given an input that is bounded. Now if the input is bounded, then what can I say? Then I can say that, okay, y of n is equal to 2u of n plus 4, which actually can be written as y of n is having two parts, because there is u of n. There will be, for the time period t greater than 0, u of n will be equal to 1, so I will get 2 plus 4, which is equal to 6. So I will get the value of 6 for t greater than 0, and for t less than 0 its value is going to be 0 plus 4, which is 4. So for t greater than 0 its value is 6, and for t less than 0 its value is 4, and never its value is going out of bound, which is a bounded output, Therefore the system is stable. So like that, you have to look for each and every case to find out if the system is stable or not. With these two classifications, we will end this second part of systems classification. Thank you.